Please hold while your passcode is being verified. Please wait for the tone, then say your name and press the pound key. At the tone, you will be the
second
caller in the conference. To mute or unmute your line during the call, please press *6 at any time.
In the Duluth office, but we thank you for joining us. We are recording this so that you'll be able to view it later at your convenience. So, as we begin here, let's take a look at where we're going. I'm going to go ahead and share an application with you just to show you what we'll be covering today. And what we're basically covering is what you see here is a small application made with locating the part, checking for spots here, and a gap check. But the tools will be a patterns tool, a histogram, and an edge tool. And how they interact together with this is as we move through the different images, we'll notice how the tools will also move because we have this fixturing device denoted by this green crosshairs down here in the lower left-hand corner. And as we go through the images, we do have a larger gap here, and we have some spots on the gasket, and we will be putting in some logic for those to be able to pass or fail those functions. So that's basically what we're going to show you how to do today. Let's jump back into our live meeting here, and we'll go through some slides showing you exactly what we need to do. Okay. What we have here is our objectives, how to learn to use the Find Patterns tool, and how some of these tools, adding different spreadsheet tools and linking them to the Find Patterns tool so that they can track as your part moves in the field of view. And let's describe the structures that build these and the auto-inserted functions that follow. So first, inserting a tool, we have a palette over here, a tool palette with our different functions, vision tools, geometry, mathematics, different functions over here. We also have a tab here called snippets, which are groups of tools built together and help shorten the task of getting the application running much more efficiently. What we do when we drew the Find Patterns tool is we have two functions to do. We have to train the model with the Find Patterns tool, and then we have to give it a search area for the model to look in. So what we do with this is we draw the model box around the area that we want to learn, and then we draw the search box to indicate where it is to look. The tools are pattern matching and edge type tools, and we'll look at some of those as we go along. As we look at the next slide here, the outcome is the only thing you will see here is the crosshairs is telling you the resultant is we have found the part, and this is the location that you have given it to indicate the center of it. How this is used is it determines the XY location here of the part in respect to the imaging chip, which is, you remember, starts out at 0, 0, and if it's a 640 by 480 CCD, this would be 640 by 480 down here at this corner. So this is why it will give us an XY coordinate position for the center of the crosshairs. It will also give us angle information if it rotates, and it is some capabilities of scaling, plus or minus 10% as it indicates here. How we go about training it is, this slide right here will indicate that we do teach it a model area. Now here we're just taking a section of the gasket. We could train the whole gasket as the model also. That is true. But since this gasket, if I were inspecting this hole right here, if it found the gasket far to the right here, this hole would be outside the field of view. There would be no need to search the whole gasket. Whereas with this, if we just learn the corner of it, and our search region here is halfway across our field of view, as this model region goes outside this, of course, this area right here would also be outside the field of view and not be able to be inspected. So we can modify our search boxes to be much smaller, taking up less processing time to process all those pixels. The tool that we'll be using in this demonstration will be the Find Patterns. We also have a PatMax tool, which we go into discussion later on. One of the things to consider when you start drawing in the spreadsheet, most of the things that we learned in the EasyBuilder are listed out for us in the result table. In the spreadsheet, we can draw the tools in the spreadsheet, but there's not much explanation with them, so it is best to sometimes put comments with them to be able to assist the people behind you to describe what the tool is actually doing. Then, once we've got the description written, we can drag and drop the tool into one of the cells in the spreadsheet. Once we do that, it will open up what we call a property sheet. In that property sheet are the settings to be able to adjust what you want the tool to do. This one has many different settings in it. Some have more, some have less. This one, all the tools will always reference an image function, an image cell, which happens to be A0. That is the one that is always there. It is the one that you cannot alter or change. We also have what we call image filters. So the image filters would also reference A0, but this tool itself might reference a different cell with that image filter. But realize all of them will default to A0, the original inspection image. There's a Find Patterns tool, so we won't fixture it to itself, but we will need to teach it a model region and then determine what the search area by the find region. The model settings we'll get into later, but those are setting it up whether it's going to be an area model or an edge model and different settings there. So let's take a look at the actual teaching part of this. Here we have the graphics, the boxes. Once you open up the model region, you would have to move this model region over what you wanted it to teach, in this case, just the corner of the gasket right here. And then you would have to OK that green checkbox or double click within the area. And then you would move the search box to find how large you want that within the field of view. For the object to be found, this part to be found, it must be contained within the search box, and that's what we're saying right here. The entire model region must be within the search box. So if this model region falls even on top of this, just a little bit, 1 or 2 pixels, it will not be able to find it. You're going to be able to have to enlarge the search area in order to find that. So that's what that's indicating right there for us. Some of the different properties here, as we said, we go through the select the model region. Then you can click on the graphics, edit graphics up here in the top of it, or merely just double click on the model region here, and that will open up the model box to be able to configure around what parts you want to learn. And then you can either click enter, double click within the box right here, or click on the green checkbox, which will be in the top menu bar above the field of view. As we go on here, with the Find Patterns tool, we also have the model settings. As I said, we would get to these in a little bit. What we have here is the area or edge. You can select the 2 different types. You can pick whether it's fine, medium, or coarse. This is talking about the granularity of the model that it's learning, 4 pixels, or 0 to 4, 4 to 8 pixels. And accuracy is dealing how many steps it's using to move that model across the search area. More on that a little bit later. Here we have the offset row and column. Row and column are the same as X and Y position, and why this is offered here. When you learn that model area, it will find the center of the model and move those crosshairs, and that's what will be the pick point of that part. Now, not necessarily that's where you want it to be picked up from if you're using especially a suction device, a vacuum cup. to pick that up with some sort of robotics. If there were a hole there in the exact center, as in the gasket, if we just learn the whole gasket, the center is a rather large portal hole, you would not be able to pick it up with a suction device, so you'd want to offset that row to move those crosshairs to a more solid area on that. The model area. Here we're looking at the area model versus the edge. Area model, we're learning both all the dark pixels and the light pixels. In this, so we're learning the entire area here, which that would also include any of the defects in the conveyor belt that it was sitting on. Another model to use is the edge model, which is the one we'll be using here in class, which just finds the boundary edge right here. And then this is why the crosshairs are right here. This is indicating this is the center of where we're looking at right here. And that is a edge model, which is using not just dark and light pixels, but is creating a geometric model. In other words, we have edges, curves, and perhaps even some other models you'll have holes. The more features you have with an edge model, the more accurate it would be to be able to find that within the search area. The area model, as we said here in the slide, may be better for smaller areas and is again not so well defined because an edge is looking for geometric shapes, but if it doesn't have so many geometric shapes, the area model would be a better choice to use. Now with the edge model, if you have a very well-defined edge, which backlighting would give you, that would be an excellent choice to use then is the edge model here. Some other information, as I said, when we get back to this. The coarseness here value is talking about the granularity of the features themselves. Fine, so now each features must be at least 4 pixels in size. Medium, 4 to 8, and of course coarse would be larger than 8 pixels. So depending upon what you're looking at, how fine the features are, it would depend on what you put here. Accuracy is, as we said, how big a step we're using in that model area, in that search area. We're going to take that model and step it across it, left, right, top, down, rotate it in that search area. And it just depends on how big or small a step it is. Of course, with Fine, we're taking very, very small steps with it and superimposing it many, many times in there. And if we go with the Fast, we're going to be taking very large steps and superimposing the model in the search area and doing it very, very quickly. But we'll be missing some certain areas. Here's an example I can show you with the different criteria, coarse, fast versus fine, accurate. If you'll note here, if we look at the center crosshairs, this is really what we want to find is the center of this part. And as you can tell, between this one to this one to this one, visually it is very hard to tell whether they have whether they have moved a few pixels or not. This one, of course, is the most accurate, but as you can tell by the characters, yeah, I'm following almost every one of the character outlines versus I'm just getting a ballpark idea what the figures are here and finding the center of mass. Whereas again with medium, we're getting a little bit more detail in the actual each characters to be able to define where the center points are. So again, with most applications, I'm sure coarse and fast would work out quite well, but depending upon what your application is, you would dictate what setting you would use by that. Another setting here that we can adjust is the acceptance threshold. The acceptance threshold is based on the score of the actual tool, and that is a combination of many functions within that tool, just not one, whether it's good contrast or bad contrast. There are several factors dictating that score. So of course, a perfect score would be 100, but we're saying anything above 50 if you find the tool and it finds the object and scores 80, this one would pass no problem. The situation, and this is only used with the pattern find tool here, is the threshold confusion. What is it doing to help speed up things? If the score is 80, which is above 70, it's saying yes, go ahead, that is the pattern that we found, and I will use that locating crosshairs as my positional tool. But what we're saying at 70 is, if the score scores at 60, somewhere in here we're saying, well, maybe that's not what the pattern is we taught. What we want to do here then is go into phase 2, which is it's going to run then, it's going to re-evaluate the image at full resolution. We run it at phase 1 at half resolution, so thus if it scores above 70, we're pretty sure that is the part that you had learned. But with this, since we're running at half resolution to help us with speed, we're going to say if it falls below 70, we want to retest it at full resolution. Then if it scores above 50, even at full resolution, it will say, yes, that is the object that we learned, and use that as my pattern, the crosshairs from that tool itself. So that is the difference between threshold acceptance, threshold confusion, and here are some of the moderations for it. To run it fastest, of course, just put them both at the same score. There is no baby zone. It will always run at half resolution, and go ahead and pass anything above 70. If you wanted to always go into full resolution, phase 2, put the confusion score at 100. It will always run at full resolution, and anything that scores above 50 will pass. So those are the differences there for that one tool. Then once we've drawn the tool, we've made all those settings in there, there's a different category here called Show, which actually to me is not really high at all. It should say Show when selected. So when you select the tool on the spreadsheet, when this is here, it will show the graphics for it. When you are not clicked on that cell with the tool there, the structure, it will not show up. So when you are not clicked on that cell, if you have this one, Input and Results Graphic, it will always be showing the visual graphics on the field of view for you to see the tools at all times. This is because when you get several tools on there, it can become very confusing and cluttered with the graphics, so they only want to indicate certain tools to be able to be shown. That's why we have this option right here. Moving on, once we've drawn the tool, this is what I meant by selecting the cell right here. If it's selected, you'll be able to see the graphics. Now, with this tool, the green crosshairs are always shown for you. So what we have also up here is what's called the auto-inserted function, meaning in this patterns tool structure right here, and that's what we're saying right here, holds a lot of information. It has index numbers for each one of the locations that it found, and this is X, Y, and angle information. It's at 100% what it learned of, and the score is 100. So this is the information that it outputs for us, and we'll be using some of this information later as I get through some more of the demonstration in the lab. Talking about the structure a little bit more, there's multiple values contained within that structure. Each one will have Find Patterns tool, Edge tools. There are many different categories to look at, and there's different information in each one of these structures. What we get out of them is when we show them in the spreadsheet, these are all within the Patterns tool. There's much more information than just what we have here, but these are the items that are most often used in the spreadsheet when we use it. We can get more by getting get mean, get average, get different informations from there, which is a different class we can learn from there. One thing about the auto-inserting function, once you have opened a proper sheet for the first time and indicated how many of these index items you want to be auto-inserted, what this slide is saying, if you said, well, I wanted more than one item shown, I wanted 4 index items shown, you only put 2, you cannot open this property sheet and put in 4. It will always indicate 2. So you would have to redraw that tool and indicate 4 and change that number at that time. So that's what we're saying with this slide right there. And so let's take a look at how we can do that. Looking at application. Now this is the application right here. We have these different tools, and I'm going to just go ahead and go to this. I already used this as an example. Here's the patterns tool structure, histogram tool structure, the edges. I'm going to go ahead to a new application here. And demonstrate this process. First thing I want to do is put in a comment, tell me what it is, just to help me later on when I come back to it. So I'm going to put a locate part here, and I'm going to go over here to our tool palette and find the patterns tools here, and here's a find patterns tool, and you can click and drag this over to there. It will open up. It doesn't look like much, but as we say, we got to teach it a model region. So I'm going to click on this one. The graphics come highlighted, so I'll go up here to edit graphics. Now I can teach anything I want. I can teach this, but for demonstration purposes, I'll go ahead and teach the corner like we showed you in the slides. And we can click within here and enter, or go up here to the green checkbox and check that. And we have learned a region there, as indicated by this green outline right here. So we also have this blue outline, which is telling me that is the search box. One of the things we cannot forget to do is go here to the find region and move that so that the area will be found. Now the reason why I'm drawing this box is like this, because if I find this edge over here, all these holes, if I'm checking for these holes, will be outside the field of view. So there is no need to search and find the bracket or the gasket here over in this region. So I draw it right here, go to the green checkbox, and find that function. The model settings, if I expand them, they are on edge, medium, medium. Good setting to be left on. So we're going to go ahead and just leave those as they are for now. Number to find, since this is a locating tool, I just want to find one. Now if I were counting, I'd have multiple numbers in here, depending upon the number that I want to find. The angle range here is important to us because what if this object rotates slightly? Now I could rotate 360 degrees. If it did, I would put in 180, which is plus or minus. Now this object's be pretty stable. It's always going to be presented in this form. So I'm only going to go 45 degrees for its angle to be able to find that object within the search area. And these we had already gone through and discussed earlier. I'm going to go ahead and say OK, and if you will, note up here what happens to this locate part. Indicating with these numbers that it found the part. As we go over here, yes, I have the green crosshairs right here, so we have found the part. And it's index 0. If it was a counting tool, I would have an index 0, 1, 2, 3, 4, 5, depending upon how many I wanted to find. But this is my XY position of this object, 324 by 100. So if we go to the overlay and I move my cursor to right about here, if you'll notice down here in this corner, it's around 324. So it's finding it about right there. And as we go back here and indicate with the patterns tool, yes, as you can tell right there, that's approximately where it is. Yep, 323 by 99. I'm right about it. So that is finding the edge of the gasket right there and doing its job. Go ahead then and jump back into the application and look at another tool. We were checking for spots there, and that was the extract histogram tool. So let's take a look at how to do that tool. So what an extract histogram does is it calculates the values, pixel values in here between gray, the grayscale, 0 being black, 255 being white. Now we have not talked too much about thresholding in that, but we determine black and white pixels by a threshold. Otherwise, they just have a value of 0, 100, 255, or whatever. But we'll be able to go into that a little bit later. Some of the extract histogram tools, the same objects we had before here, checking for the holes in here and checking for pins, checking for spots with this one. So it can be used various different ways. Another application here, checking for fluid within the bottle. course, these are going to be different grayscale values than if it actually has some liquid in it. Again, now we're going to go ahead and put some descriptive comments in there so we can help the people behind us know what that tool is used for. Then we're going to go ahead in the extract histogram group over here in the tool palette and put that tool in there. And once this opens, as you can tell, there's not as many parameters to choose in the extract histogram property sheet as there was in the find patterns tool. Here we have the fixturing, which is the locate part, and we just get to indicate a region with this one. No search region, model region, well, this is a model region. No other model settings, just the fixturing and region to use. Once we've done that, and we'll get to that in a second, we're going to place that tool on this gasket right here, and we'll notice we have 0. We have here 0 to 255, and we have this graph here with a line up in the middle saying pixels to left will be black pixels, pixels to the right towards 255 will be white pixels. Not too much to indicate in this one, but as we look at this now histogram with the spots, we can see a large pile of dark pixels, which looking at the image here, yeah, we do have a lot of dark background. And we have what we call the spots right here, which are around 100, 150 for grayscale values. And when you look at this, yes, you can indicate that there are some white pixels in there. So that's what an extract histogram will do. Will give us the amount of dark and light pixels by drawing a threshold down the middle here, or in between the values. So that's our extract histogram tool itself, and within that we will have the structure, and these are the auto-inserted functions, which don't have row and column. What they do is they have different values, especially contrast. Now, a low value of contrast of 5, contrast is the absolute number between 0 and 255. So if I have a pixel at 150 and another pixel at 100, my contrast between the two is 50. So this one indicates I don't have a lot of contrast here, so I am probably looking at this image right here with that. So if the contrast is like 180, I was probably looking at the extract histogram tool with the actual spots on it. Okay? So I take a look, and there's again different pieces of information here offered with that also. Within that structure, which wasn't auto-inserted in the cells, is also these different functions in the structure: his mean, his max, the different sum of all the pixels within that range. So again, that information is there. It would have to be get his mean, get his max, different functions to be able to get it. All right. Some of the other areas here, again, we have to remember to fixture the tool so that the actual function will follow with it as the gasket gets in different locations. In order to do that, we will have to fixture it to the patterns tool right here, and that's what we're saying. We're in the extract histogram property sheet. Remember, we only have fixture and region and show. So there's only 3 parameters to choose from. So under the fixture tool right here, we have row, column, theta, which is the same thing as row, column, angle. And so we're going to be able to indicate these numbers by referencing these cells within that function itself. Okay? So let's take a look. Once we've done that, then we have the crosshair, and as it moves, it will then move accordingly with it. Then once we do there, we'll get into the pass-fail, but let's go ahead and back here to the Insight software, and let's go ahead, now that we've got that up there, let's go ahead and put a spot check, we'll call this. And our patterns are done. Let's go up here to our histograms and grab an extract histogram and put it in there. We'll draw the region here, so I will click on the region here in the graphics. I will grab it and move it up here. Notice these handles that we have an X and a Y and a bend and a reshaping different function here, and and rotate. So I can rotate it, and I also can bend it to more of a pie shape there. So we're going to go ahead and maybe I'll rotate it a little bit more this way. There we go. So I'm going to go ahead and leave it there. And once I've done that, I've got to also remember, though, that if I do not fixture this as the part moves, this object, this tool that I just drew here, will stay in that position relative to the CCD, imaging chip. So I must fixture. So I'll go over here, expand fixture. I will double-click on row, which then turns this into a lavender pink color. And it's saying I'm looking for information to put into it. So I'm going to highlight row column angle. I'm going to hit the green checkbox, and then it populates it with that cell address, E, F, and G. Row 2, which is where our row 2 here, E, F, and G. So it populates that with that. I'm going to go ahead and tell it to show the graphics as we use it, and I'll say OK. And there we have it as we look at it. It is fixtured, so as I show you this indicator right here, and we rotate this object, you can see it is moving with it. So by a graph here, we're getting a little bit different graphs here as we rotate it by. Okay, that's back to our original image itself. So that is telling us 9. If you would, go ahead and make sure you take a look at this number here as we go through here. Huge contrast because we have light pixels and dark pixels, meaning we have a high value change, 150 between these two. So let's go ahead then and take a look at the next slide here, which is going to be talking about the logic to assign to this. Because notice the tool is just giving us information. It's not passing or failing it. It is merely just telling us what the function is doing. So what we want to do here is decide what the pass-fail information is. And we're going to have to look at these values here and decide which one is going to give me a pass or fail piece of information. So what we're going to do is go ahead and, it's saying down here, put all the pass-fail information in one of the columns here to the far right. I'm just going to go ahead and put it over here under the histogram structure so that we can follow that just for the examples given here for this lesson. All right. So let's go ahead and take a look how to put that logic in that. All right. So let's take a look. I'm going to go ahead and put some pass-fail criteria in here. So I'll put what I'm doing with it. Move that over to right here. So here, I need some logic in here under the histogram, so pass-fail information. So what I can do here is type in an if, and I put a parentheses, and I can reference this contrast cell because it goes from 10 to 150, a really large swing. So if this cell is less than, and I'll put the less than indicator, is less than, let's say, 100, then I'll put a comma, and I'll put a quote here, comma, and another quote. If it is not less than 100, it will fail. So as you're telling right now, we go through here this, and as we look here, we do have spots and numbers quite high, and it does fail. So that is how we input the logic for that function right there. So in the pass function here. Let's take a look then back at the slides. Another tool that we can learn about is we work with the locating tool, find patterns, and the histogram. Let's take a look at the find segment tool. Now what this is going to do is give us some information on distances between pair of edges. Let's take a look at how that can work for us. So what we want to do here is take a look at this tool. Again, we have lots of different parameters in the property sheet, not like the extract histogram, which is 3, back into like the find patterns tool with fixturing, region, color, find by criteria, acceptance threshold. We don't have a confusion factor here, but just an acceptance threshold for the score, and different pieces of information here, which I'll go into with you. So once we draw the tool across the gap here, which we're going to check, we have an edge 0 and an edge 1. Most everything in this programming starts with a 0, now with 1, so just realize we're always dealing with 0 to 1. So as we go along here, we have the object here to moderate again. It's only going to output two pieces of information from our edges structure, a distance and a score. And it's going to be fixtured to the crosshair so that it will always follow across this gap in order to find it. So let's take a look at how to do that. So we're going to do a gap check here. And we'll go ahead up here to the Edges tool and put a Find Segment tool in here. And I go straight to the region, edit the graphics because I want to put it on the area I want it to inspect. Notice this Find Segment tool only has one arrow. This is the arrow that needs to cross perpendicular to this edge. So I'm going to have to rotate this edge so that it crosses this edge perpendicular, not parallel with it. If it were parallel, it would not be able to find that edge. So once that's done, I can go through here and pick the color. This segment color right here, the widest gap is white. And I have several strongest edges, widest, narrowest. This is the widest white gap here. And I can do that. Acceptance threshold here is 25, much lower. We have some other criteria here. Angle range, as we saw with the Find Patterns tool, could go up to 180. But this one, you'll notice, only goes up to 10. This is not taking care of rotational information. This is taking care of how parallel these two edges are across the gap. So again, you don't need a great range. And what this does is, it's saying if the edges aren't parallel to each other, it will not lower the score as much. Now, if I have it at 0, it means the edges must be parallel, and any unparalleled edges will lower that score. So what we're doing is we're allowing a little bit of a fudge factor in there for it. So I have not fixtured this, so if I were to quit this and leave and the product moved, the region would not move with it. So I'll go ahead and go up here to region and double click on row. Again, it's waiting for information to be put into it, so I'll go up here to the patterns tool, locate part, fixturing tool, so I'll do row column angle, hit the green arrow, and it's inputted in there so I can say OK to it. Again, it doesn't give me any pass-fail criteria. It just merely gives me some absolute numbers. So let's take a look at that number as we rotate. And it is following with it. I can't tell because we can't see it because I forgot to show all results so that we can see it as it goes. It's at 68. And as we rotate it again, we're across a much larger gap. Let's take a look what the results are from 68 to 87. So again, we're going to put some pass-fail criteria in here. So I'm going to go ahead and copy and just go ahead and paste this here so I can get it done very quickly. And then I can put in here if distance here is less than, let's say 72, then I'm going to go ahead and pass it. And by passing, I'm indicating with a 1, and failing, I'm indicating with a 0. I'm doing a little bit different here from the pass-fail, from words into numerical values, which we can do a lot more with. And so it is failing right now because the gap is larger than 68, so it's 0. And as I get back to less than 72, it turns to a 1. So a 1 is pass, and a 0 is fail. So those are the Find Segment tools. So we've gone through the Extract Histogram and now an Edge tool. and we put some logic with both of those. Take a look back here at our last tool that we want to take a look at, and that's the Extract Blobs tool. As you can tell, again, this property sheet, we have lots of information to work through here on this one. So let's take a look at what we have with the Extract Blobs tool. A little bit different functionality here. What we're doing here is looking at pixels that touch each other and are of the same intensity, whether they're light or dark, black or white. We are looking in this area for these contiguous pixels in here. And we're going to be able to look at some of the definitions here. We've got some region here, fixture and region. Again, we have to look in a certain region to find them, fixture, so it moves with it. We also have a number to sort, so this can also be a fixturing tool. If when we find one, it will give us an XY location, as you'll see when we actually draw this tool. And we have different pieces of information down here also. We have something called fill hole. You'll notice with these holes in these blobs right here, our area is 3,500. As we indicate with the fill holes, we have 39. So what we've done is we've filled these light pixels that are surrounded by the dark pixels with dark pixels and made that part of the blob itself. Some of the different pieces of information that we can get from the blob is, of course, we get row column angle, so it's very much like a fixturing tool. We could use it as that. We also get some elongation parameters, so we have row column angle information. Elongation, now it's not going to be very accurate, just give us the longest axis and how wide and what the area here is spread, the values for it. Some different pieces of information in that, so we get a lot of auto-inserted information for it. So some of the different functions here, the property sheets and summary, they are the ones that with the parameters that populate the structure and the auto-inserted function. So let's take a quick look at how to do a extract blob. I'm just going to make this a hole check. And you'll notice it turned red on the screen. What it is I didn't put that apostrophe in there in the front end to make it a comment, so it thought I was making some sort of syntax like if, and, or whatever with these logic statements, but I'm not. So I want to go here and find the blob. So here we just have 3, extract, find, and sort. I'm going to go ahead and drag the extract blob tool over here. Just like the other tools, I'm going to go find the region, what I want to look for. I'm going to go ahead and draw it down here for this one. Find this one here. Green checkbox. Once I've drawn it, there is no search box area. Number to sort, there's only one in there, so I'm going to go ahead and do that. Threshold is going to be automatic. In other words, it's going to put the threshold between the lightest and darkest pixels found in here. Don't necessarily have holes in this one. Boundary blobs is indicated if this white area here touches my search area. It will not be included if I do not have this box checked. If I do have it checked, then this white area right here, which is the white blob we're looking for, I can touch it and plus go past it, and it will be still counted as a blob. Okay? The color of the blob is we are looking at a white blob on a black background. Some important information here is the limits. This is a good way to get rid of noise. Of course, we could make this down to 50 or 10 or whatever, but then we would, any specular noise, any dark or light spots on the black background right here would show up as extra blobs. So we do not want to do that. So again, once you find out the size of the blob, you can come in here and dial this more to be within the parameters. If your blob is 500 to 600 pixels here, you might want to limit that to just look for blobs that are larger than 300 and smaller than 800 blobs. And that way it will not be finding all these other blobs. So since I have said number to sort is 1, it will auto-insert 1 for me and give me all this information right here. And notice the area here is 544. Now I did not fixture it, so I'll have to go back here. I do this often. Notice there's zeros here, and go ahead and double click on row. Go up here to row column angle. Check that. Say okay, so that it tracks with it. As we then move this, it is, our score here is staying 500 and 540. But here as we go, change to 225 because, as you'll notice with the blob itself, yes, I've got some flashing in there, so yeah, that would change the value of it. So if I had a pass-fail criteria, I'd probably look at area right here to determine my pass-fail criteria for it. Okay. So that is how to draw a extract blob. There's different ways to draw it also. I could draw the region around the entire gasket and rule out this large blob right here with that minimum maximum information. But again, just we want to show you the different tools and to be able to fixture these tools to the location part of the fixturing patterns tool that we have here. Going back to the slides just for a quick second here, we have a few slides here in the end to go through to just review to come up. So the property sheets are here to help us add parameters, to change the parameters, that is the auto-inserted structure itself here. And then the Find Patterns tool is a locating type tool which gives us our row, column, angle information, then populate all the other tools that we put on the spreadsheet to be able to find the specific part, specific placement on a part by using the Find Patterns tool. The two phases of Find Patterns are you must train it first and then indicate where it will look, the searching area. Well, that concludes our session for today with the tools and fixturing. Again, this will be a video on the website, so you're welcome to download that, go to the website and get those for you. And next week, we'll be looking at continuing on with our EasyBuilder spreadsheet session and be going in application development next Friday. Again, thank you, and we look forward to seeing you again. Good day.